Hey guys, Mrs. Traver here. Today we're going to talk about chords and inscribed angles. So let's jump in. First thing we're going to talk about is chords, and I want to review some vocab words with you from circles. A couple of them we've seen many times before. For example, radius and diameter. We know these, we've got them down. No problem. The new one today is chord. So a chord is a line segment that touches two edges of a circle but does not go through the center. If it went through the center, that'd be the definition of a diameter. So chord is what we're focusing on today. Some ones we could look at in the future are secant and tangent. Those are lines, not line segments. So notice they have those arrows on the end, but they have different properties. Today, we're talking chords. So here I've got a chord AB, and I want to talk about what we would do if we drew a line perpendicular through that chord. So perpendicular is at a right angle, and if I drew one at a right angle through the chord and I started heading this way, you'll notice one thing right off the bat, that it goes through the center. So goes through the center. And let's label this line, let's call it where I cut it here was X and the center C. So we'll say XC goes through the center. That's one property. Another property is that because it's perpendicular, it actually also bisects the chord. So not only does it go through the center, but it bisects AB so that these two pieces are congruent. AX is congruent to XB. We know these two facts about chords here based on the perpendicular bisector going through the center. We'll use this as well as a couple other things to do some example problems below. The two other things that'll come up most frequently are the fact that all radii are equal and congruent to each other, which is kind of like a duh thing if you think about it, but you'll see it in problems and it won't be as obvious as it looks. The other thing that we'll use a lot throughout the problems is our Pythagorean theorem. Because of the fact that there's that right angle there with the perpendicular bisector, we'll create some right triangles that we can utilize. So let's try an example here with the first one. Here's our first guy. So let's see what we can do. Again, I'm right off the bat noticing some right triangles here. So if we kind of take a step back, maybe we can use that. I've got this 11.5 in the right triangle and this X, and I'm kind of like missing some information. If I had one more bit of information here, like this hypotenuse, I'd be good to use Pythagorean theorem. But what you'll notice is I actually already do have this length of a hypotenuse. It's a radius. It goes from the center to the edge. And I was already told that the radius over here was 20.7. So this is also 20.7. I can just fill it in. So right after you notice you've got a radius, every other radius right off the bat is 20.7. So now I can use this right triangle, because this is also a right angle, to use Pythagorean theorem, where I've got an A and a B as my legs, and C as my hypotenuse across from the right angle. So let's jump in and use that to solve this problem. It'll be pretty straightforward after you fill in the stuff. So A in our case is X, B in our case is 11.5, and C is 20.7. Let's clean some things up here. Some of you are able to jump right to the answer here by using your calculator, and if that's you, that's fine. Otherwise, follow along for the steps in between. I'm going to get these worked out. 11.5, oops, I do it right. 11.5 squared is 132.25. And where we have 20.7 squared is 428.49. Next, let's get rid of this 132.25 from both sides. That's gone. And we'd have this number subtract 132.25, and we're left with 296.24. On my right, on my left, all I'm left with is my x squared. My last step here is to square root both sides. Root. I've got about 17.2. In your examples, it'll ask you to round to the nearest tenth, so I've done that. So our x is 17.2. Final answer. Let's look at the next one. Here's our next guy. Let's see what we've got. More right triangle business, I see. And The x I'm looking for here isn't a part of my right triangle. So that's kind of weird. What we could solve for, like, I can see it'd be no problem if this had been x, that'd be cool because I could use this right triangle and solve for it. But maybe we can use that still. So here's my mindset. What if we did solve for this? I'll call it something different. I'll call it y. Then notice that we've got this length here from the edge to the center. That's a radius. And we also already have the radius is 10.7. So if I can solve for y, and I know x and y together make up a radius, just 10.7, I could use that. So let's solve for y first with this right triangle. So I'm going to rewrite my right triangle. You don't have to do this part if you don't want. But I've got y as my height, 9.8 as my base, and my radius is 10.7, or the hypotenuse. So let's solve for y first, like I said, then we'll plug it in here, and we'll have x, so two-step problem. All right, let's jump in. We've got a squared plus b squared equals c squared. In this case, I've got y squared plus 9.8 squared equals 10.7 squared. Take a minute and solve this piece out. Pause your video now and make sure you've got Pythagorean theorem down. So get an answer for y equals right now. Pause your video, ready, go. All right, you're back. Hopefully you got 2.8 approximately when you did Pythagorean theorem. So now, back here, I've already got this piece is 2.8. I'm going to plug it in my spot. So this 2.8 goes here and here. So notice, again, we know the radius is 10.7. We already used 2.8 of it for this piece. What's left for x? Let's take away 2.8 from both sides. And I'll be left with x equals 10.7 minus 2.8. Oh, maybe I can type it right. That'll work out better. 10.7 minus 2.8 is approximately 7.9. I say approximately because we rounded earlier. But there's my final answer for the second one. Let's look at the third one. All right, last one, chords. Let's see what we've got here. We've been playing the radius game so far, so I'm kind of thinking that's kind of a gameplay that'll happen again. I noticed I was given the radius as 13, and I've got this other radius over here. From here to here, that's also 13. So we might be able to use that thing where we have like x as a piece of it and y as another piece to use. So let's kind of think about that. If we solve for this y, then I know x plus y is 13, kind of like the last one. So let's kind of reframe our mindset because I don't know how I could solve for x right now. But I could maybe solve for y if I made a right triangle. I don't see any right triangles right now, though. Let's create one. I've got a 10 here, so I kind of want to work with this area. What if I created this right triangle? Here's a right angle with perpendicular bisector on the chord. And what I just drew in, that blue line, is another radii. So there, I could use this right triangle with the 10 and the y and the 13. Then I'll have y and be able to get x. So let's do that. And I'm going to, again, redraw the right triangle. Height 10, base y, hypotenuse 13. And we'll set it up with a squared plus b squared equals c squared. You're getting pretty good at these. Do the work out right now. See what you get for y equals. When you come back, I'll have some work. So pause your screen right now. All right, so hopefully you got approximately 8.3 for this y piece. So let's plug that in for what we have in this spot here. We said it was about 8.3. And so in our equation, x plus y is 8.3. I can use it plus x to get a radius of 13. So let's take away 8.3 from both sides. And I've got x equals 13 minus 8.3 is 4.7. So final answer there, 4.7. All right, so we've done several examples of chords here. Hopefully these ones look good. Let's look at the next piece of today's lesson, inscribed angles. These are actually more straightforward than chords. So let's talk about the one property with inscribed angles. It's going to be kind of obvious once you jump in how it works. So let's see. Here's the rule with inscribed angles. First off, angle B is an inscribed angle. So that's what we call angle B. And then this is arc AC. We've talked about arcs before. So here's the deal. If you look at the measure of angle B, it is equal to double the measure of the arc's angle. So notice how it's kind of like a flashlight is what I think about. So this flashlight projects out to this AC. This arc that's included in it is just double that angle measure. So equals, 2 times the measure of angle B equals measure of arc AC. So that's our rule. Let me show it to you in action though. It'll make a lot more sense. So here's how it plays out. Say you're given this angle measurement of the inscribed angle is 30 degrees and you're looking for arc AC. You literally just have to double it. That's it. So from here to here, we'll do a times 2 to get 60 degrees for arc AC. Not too bad. Let's see what happens with this next one. Say you are given, this is 60, you kind of already know where this is going. You just want to, let me get my colors matching here. Say you were given this is 60 degrees and you're looking for the measure of angle B. You just simply want to, at this point, not times 2, but you're going to go this way and divide by 2 to get your answer, which we already know, obviously, is going to be 30 degrees. So you can see how they match up. The little one to the big one, just double it. Let's do some examples here. So let's see, we're given this question mark arc over here. So right off the bat, I want to make sure I know what I'm looking for. I'm looking for an arc LJ. And let's see, if I look around the circle, it's kind of nice if you're looking for an arc to have a mindset of, let me see if I can fill in every other arc. So I already have arc JK. I don't have arc KL though, but I can sure get it because notice arc LK comes from this inscribed angle 71. So if this is 71, then I just need to double it from here to here, do a times 2. 71 times 2 is 142. And now I can see I've got everything around the circle except for my question mark angle. So the whole circle around is 360. I already used 127. I already used 142. I am left with what? Let's see. I'm left with minus 142, enter 91 degrees for the measure of arc LJ. Not too bad. Let's do another one. All right, let's see. This time we are being asked for an inscribed angle up here. So let's notice it goes to this arc. And I have the other 2 arcs. Maybe if I find arc DC, then I can go backwards and find that inscribed angle. So let's do that first. Let's find arc DC first. I notice the whole circle is 360. I've already used up 164 and 136 of it. And that'll leave me with the measure of arc DC. Let's find that first. 360 minus 164 minus 136 is 60. So I know this guy is 60. Let's go backwards to our inscribed angle. That would be dividing by 2, and we'll get 30 degrees there. So measure of angle B is 30 degrees. Not too bad. I think we've got one more. We'd only have 2. Thought there was another one. All right. Oh, there they are. I was really lost there. We have a couple more. All right. This one looks a little bit different. It's got a triangle on the inside. The next one's going to have a quadrilateral on the inside. So let's see. We're looking for an arc up here, arc VW. So kind of like I said before, let's see if we can fill in the rest of the arcs. I've got this one here, VX. That's fine. I don't have arc XW, but notice XW, I think of this flashlight again. I can get XW from this inscribed angle 46. So let's use that 46. From here to here, we'll do a times 2. 46 times 2. 40 times 2 is 80. 6 times 2 is 12. So 96 degrees out here. And I have all the other arcs except for my question mark guy. So let's start with our 360. Take away our 96. Take away our 148. And we'll be left with what we want, measure of arc VW. 60, take away 96, take away 148 is 116. All right, one more. Here we go. All right, so, whoa, we got a lot going on. So quadrilateral, and we're looking for an arc, XW, out here. We have this arc 78, that's cool. We don't have either of the other arcs though. So let's see. What else do we have? Ooh, how about this? We have this angle here. We have this 74. That's the only inscribed angle we have. And if we highlight it and look at the spot that it shades in, I can see that arc XZ, that whole big piece, is going to be double 74. So from here to here is 74 times 2. 74 times 2 is 148. So if that whole piece is 148, and I already used up 78 of it, left 70. So my measure of arc XY is 70 degrees. All right, that's it for inscribed angles. They kind of are a game to play, and there's several ways to do these problems. I did them the first way I thought of, but you could definitely have played these out in other ways. For example, in this problem, you could have actually used the sum of interior angles of a triangle. Would have been a longer way to go about it, but totally would have worked. That's all I've got for inscribed angles and chords. I hope this video helped you guys, and if you need anything, send me an email. I will see you next time. Bye.